So the airbag, when it inflates, allows you to come up against a collapsible cushion, which will transmit your body into a deceleration rate in which that it can survive or which that it can tolerate. When the car enters into a crash, there's a crash sensor that is specifically sensing the momentum, the deceleration of the car in a specific vector, a specific direction. Once it says, yes, we have a crash, it then sends an electrical pulse up to the inflator and specifically to the igniter. Once the propellant ignites in the argon system, it starts to heat up, produces off gases, and it's an exothermic reaction. It off gases, produces heat and a little bit of residual gas. But for the most part, what we're getting from the propellant is just heat. That heat then is transferred into the stored gas, the stored argon mixture. That as the argon starts to absorb the heat, it starts to try and expand. The sodium azide system has no stored gas to start with. What happens then is in the reaction, the sodium azide breaks down exothermically, gives off heat, and also produces nitrogen gas as the sodium is then being oxidized to sodium oxide. And the resultant materials coming from that then are hot nitrogen gas, sodium oxide, which is going to be a solid at that point, and copper metal. That then is transferred out of the inflator through a fairly heavy metal mesh screen, well, like the screen you see in your screen door, except it's several layers thick. Whereas in the argon system, we're only using the propellant and the pyrotechnic reactions to augment or to add to the stored gas's pressure. So we're using the stored gas as the primary inflator component. The energy of activation is the amount of energy that's required to actually break apart the starting chemicals so that they can go and continue the reaction. In setting up the reaction rate or the inflation rate of the inflator, there are basically three specific issues that we try and address, and that is how much propellant we have in there, because that's going to directly say how much heat we're dumping into the system. The second thing is the burn rate of the propellant, or how it burns over a period of time, and that is controlled by how thick it is, as well as what the burn rate and the pressures are of the propellant. And the third thing has to do with the gas as it's leaving the unit has to pass through what we call an orifice. That controls purely from a mass flow standpoint. The pros of a argon-based system are primarily the fact you don't need a filter screen. You are using the heat to your advantage instead of it being a byproduct of the reaction. You're using that as one of your primary issues. All the gases coming out of there are very, very clean. The argon-based systems are proving to be a lot more repeatable. There's less variation due to performance, in the performance, and that's always very desirable. Higher quality products, as well as some cost issues. That's another big issue. The argon-based systems are usually less expensive to produce. But I think the primary reason that the sodium azide systems are being replaced by argon systems has to do with the environmental issues associated with the sodium azide-based system. The sodium azide being a toxic material. A pro to the sodium azide-based system would obviously be the fact that you don't have a stored gas to worry about leaking out over 15 or 20 years, which is a big issue. In the argon-based system, the chemical reactants are the hydrocarbon-based fuel and the oxygen, which is stored in the system. And so the reactants that are, or the products that are coming out of the inflator are going to be carbon dioxide, water, and oxygen, and nitrogen gas. The original size of the stored gas is in a typical driver inflator would be approximately 5 to 6 cubic inches. And that then expands out to roughly 1 3/4 cubic feet. So it's a fairly substantial expansion. The car makers and the module makers are very specific in wanting an output in a given amount of time because they've designed their cars to react with that time frame and that output frame with an average person hitting the bag. So if we have too much gas coming into the bag, or if I put too much propellant into the inflator and get too much output into the bag, too much heat into the bag, then I will get an overfilled bag, and that may actually rupture the bag. And if the bag ruptures, then there's no crash protection from the airbag. And if I put too little in, just the opposite will happen. The bag won't fill up completely, and it'll be a soft bag, and it'll provide only minimal crash protection.